Hey, it's Avi, and welcome to another Magic Garden devlog, where we go behind the scenes about some of the things that you wanted to know about Magic Garden, and sometimes things that almost nobody wanted to know about Magic Garden. And in this case, we are going to go super deep on what I believe is the final resolution of the Blocky Cactus mystery, the Blocky Cactus challenge. So, if you have been lucky enough to not experience this bug yourself, the bug is that sometimes cactuses and bamboo would, you see how this cactus has some ice on it because it's a frozen cactus. And you see how the ice kind of like fits within the shape of the cactus. Well, you can see that this bug is that ice is not just on the cactus, but it's also outside of the cactus. And we call this the Blocky Cactus bug. And it has been a bug ever since the new engine. And you can see that this is actually a report from just yesterday about somebody running into the same bug, this time with frozen bamboo. And you can see that some of the ice is inside and sometimes it's not. And we'll talk about all of that. I want to give a huge shout out to everyone who participated in the 1,000 donut bounty Blocky Cactus challenge competition contest / help me figure out what the heck's going on here. This was super helpful to figure out what actually was going on. I think in the end, I'm like 90% sure I've figured it out. And I'm also 90% sure that I fixed it. That fix should go live tomorrow. Particular shout out to B and Jake, Princess B and Jake, who just did an unbelievable amount of like repeated testing trying to figure this bug out. And I really don't think I would be able to have figured it out without your help. So thank you. Okay, so here's the story. What is causing this? Well, first you have to understand like how we draw mutations in Magic Garden. And I think that Magic Garden's mutation, like not to toot my own horn, but I will, I think that what we came up with for drawing mutations on plants is a really clever little system because there's many different mutations that a plant can have all at the same time, and we need some way to visually represent all of those different mutations, even though a plant could have, 3 or 4 different mutations. So as you know, we have different tricks that we do visually to indicate what a mutation is. One trick that we do that's very simple is we just take 2 images and we put them on top of each other. So this is a bunch of ice, an image of ice, and we put that at the base of the cactus. We also sometimes tint. So here's an example of a pumpkin that's frozen. You'll see that not only do we have the ice on top of it, that's a sprite. If you didn't know, sprites just is the name for graphics in a video game. So this is a sprite, this is a sprite. The bee is a sprite. Basically anything that is drawn onto the screen as a discrete object. And so we're tinting this. But there are some plants that we give an extra special treatment to when we draw them mutation-wise. And those are, we call them the tall plants. There's a whole long story about why they're called tall plants, but basically it's just cactus and bamboo. And what's special about cactus and bamboo is that in addition to tinting them a little bit bluish for, frozen, and in addition to putting the sprite on top of it, we also do this thing called a masked overlay. And I can show you, actually, I did a little bit of visualization of what that looks like. So you can think about what's actually happening here is for every cactus that we want to be frozen, we actually are going to take something that looks like, oh, look, can I show you what it looks like, actually? If you look at mutation overlay, cool. So here is the mutation overlay for chilled. Or actually, we'll look at frozen since these are frozen. And you might recognize this. This is some of the stuff that gets on top of the bamboo and the cactus. But it fits perfectly into the shape of the bamboo and cactus. And the way that we do that is we do what's called an alpha mask, where you tell the computer to take all of the transparent pixels and you basically imagine overlapping this on top of the cactus, and anywhere that a pixel of this mutation overlay of all this ice would land on top of the cactus, you check and see if it's white or it's transparent. And if it's transparent, then you also make the mutation overlay transparent in that area. And if it's white or not transparent, then you actually draw the pixel of the mutation. And what that essentially does is it's a cookie cutter. It essentially cookie cuts the mutation to fit perfectly into the shape of a cactus. So that's a mutation overlay. And that technique of doing the cookie cutting is called alpha masking. And in order to do this technique, you need the mask, and we call it the mask shape, right? And I call this a silhouette because it's kind of the shape of the cactus. And for various reasons, it's actually sort of important that it be fully white instead of just any of the other pixels. Otherwise, they would get blended in weird ways. So you need this like pure white silhouette where anything that was in the cactus, any pixels in the cactus are turned fully white, and any pixels that were transparent in the cactus remain transparent. And you can kind of see, if we look at the tall plant, this is the cactus, right? So anything that's in this transparent bit stays transparent, but anything that is not transparent becomes pure white. Okay, so we understand now that we need this alpha mask, and that alpha mask allows us to cookie cut into this mutation, and then we actually overlay that cookie cut alpha masked silhouette on top of the cactus. And so there's actually 3 different visual effects that are going on with this cactus. And mind you, this is just a frozen cactus. This one isn't even amber lit or dawn lit or anything rainbow. But there's 3 different things. There's a tint of the cactus, there's the sprite overlay, and there's a masked overlay. And the Blocky Cactus Challenge is very specifically a bug with creating that cookie cutter masked overlay. And what it appears like visually is, rather than the cookie cut being in the shape of a cactus, it's as if your cookie cutter was always in the shape of a square. Well, actually not a square, a rectangle. And specifically a rectangle the size of the bamboo or the cactus itself. As you can see, when Abe creates the art for the game, he's creating it in these rectangular shapes, and those all get actually packed together in this thing called the sprite sheet, which makes it really fast and efficient to download all the game's art and over the internet, and then also fast to upload them into your phone or computer's graphics card. Because it's not a whole bunch of different images, it's really just slices into one big image. Okay, so a lot of slicing, a lot of stuff going on. But basically, all you really need to realize is that the failure here, the actual bug, is that the mask, instead of masking along the shape of the cactus, started masking as if it was not a silhouette of the shape of the cactus, it was just a silhouette of the box that the cactus was in. So essentially, this box, I don't know if you can see it, but it's like a little bit of an outline. Oh yeah, that's actually amazing. That's the shape that it was masking, not the actual shape of the cactus. And it was as if when it was trying to read the pixels to determine is it transparent or not, it was figuring that they were all not transparent. It's as if the transparency data. Oh, by the way, alpha is just another word for transparency. I've been saying that a lot, but they're interchangeable if you haven't heard that before. Okay, so what could possibly cause this, right? And the answer is, this is another demonstration I made, not of the bug, but just of sort of overlaying these things, and you can kind of see, okay, that's the shape of that box. Okay, so what would cause this? Well, first, in order to figure out any bug, you basically need to be able to reproduce it. You need to be able to do it yourself, because if you can reproduce it, then you can poke at it, you can say, well, what if I try this? Does that fix it? What if I try this? Does that make it worse? The problem is I could never reproduce this bug. And to this day, I have literally never been able to get this bug to occur on my computer, my like main computer. I was ultimately able to get it to reproduce on a spare Windows laptop I use for testing, but that was only after hours of following the method that B and Jake figured out to be able to reproduce it sort of reliably. It sounds like maybe 1 in every 2 times. And what was that way? Well, bizarrely enough, the trick to being able to reproduce it essentially involved minimizing the window and waiting. So you minimize the window, you wait, and we're actually going to wait for 10 seconds, and you'll see what happens when we reopen it. And while we're waiting for that to kind of cook, it's a good time to review the fact that there were a bunch of different bug reports about this. I have no idea how many people actually experienced the bug, because just because we only see 5 reports doesn't mean it only happened to 5 people. That's 5 people who cared enough, who A, noticed it, and B, cared enough to like track down our Discord, or maybe they were already in the Discord, and report the bug. So it probably happened to way more people. There's like, tens of thousands of people a day who play Magic Garden, and I'm sure this bug was happening to plenty of them. But something interesting was happening. You try to look for like what's in common about all these different bug reports. And one of the most surprising things that jumped out right away is that it seemed to happen on every kind of phone and browser. We got Firefox, we got Chrome, we got yesterday we got the first Android report, which was interesting. We got iOS in the iOS app. We got Discord in the browser. It seemed to be everywhere. And so that suggested to me it's not an operating system level issue. It's probably some kind of issue with the graphics code. That maybe is a bug in our code, or maybe in a bug in the library that we use to do the graphics. And what was very interesting, besides the fact that there was no commonality in terms of the device that people were using, the other thing that was really interesting is that they all seemed to have done basically the same thing right before the bug happened, which is that they minimized the window and then they reopened it, or they switched apps and they came back. And you can see that I just did that. And, when the game is minimized, we don't want to keep you connected to the server, both for your own data and also because we don't want people, AFKing, constantly all the time. And so the game, like basically any game, if it's minimized for long enough, will disconnect you. And so if you want to stay connected, you kind of have to keep the game focused. But if the window is fully hidden, then the game stops responding to the server pings, and eventually the server's like, I think this person's gone away, I'm going to kick them out, and make room for other people, for example. So what happens when you come back ends up being the key. And the game renders graphics, and now I'm about to go really off the deep end. So I don't know how much of this will be absorbed. I also think I only even understand this about 90%, so I'm going to try not to lie to you in my explanation here. But we render the graphics of this game using this technology called WebGL. And you can go to get.webgl.org and you can see a spinning cube. And basically what WebGL does is it is a API for letting JavaScript do graphics and computation directly on your device's graphics card. And WebGL is a super kind of old and low-level technology. It's like really cumbersome to use. Nobody would really ever want to make a game in it directly because it's so low level. But because it's low level and it's really complicated to do basic things, you can actually do a lot of very powerful things. Oftentimes in computers, things that are low level are faster and more powerful, and things that are higher level and more expressive are a little bit slower. And so there's this amazing project, open source project called Pixi, that a bunch of people basically got together and they're like, we're going to make it really easy to write things on top of WebGL, and also other frameworks or technologies like WebGPU that are newer than WebGL. But anyway, so that's what Pixi does. Pixi, instead of making it like 100 lines of code to draw a triangle, makes it like 3 lines of code to draw a triangle, which is great because we have a lot of triangles and squares and rectangles and things to draw. And so we use Pixi to actually implement all of these mutation things, the overlapping, the masking, the whatever. So I'm going to show you some of the code that is actually involved in doing this. And this is a function called apply mutations. I'm not going to read the whole thing. Basically what this does is it says, hey, I have a sprite. Please, here's a list of all the mutations that it has. Like it could be rainbow, actually it tells you right here. It could be gold, rainbow, wet, chilled, amber shine. Also, yes, some of the internal code names for those things aren't what we ended up calling it, which sometimes gets confusing. But you can apply the mutations, and it goes through and it does all of these different, approaches that I described. It lays the ice at the base. It figures out how to do the overlapping because, maybe you've never noticed it, but like this ice is actually on top of the burrows. But here, when it's a tall plant, the cactus is drawn on top of the ice rather than the other way around, which makes more visual sense. So this apply mutations is like the main kind of like brains of how do we actually do that mutation code. And there's special handling for the tall plants. Literally is tall plant. Well, here's a cactus. So inside of here, we go and we have this thing called the visual mutations dex. We use this term dex all the time in the code. It's like a Pokedex. It's a place you can look stuff up. And you can see, here's the stuff in the dex for dawnlit. It should be that color, and here's the icon. Here's what we do for chilled. And what's special about the tall plants is that they have this special overlay tile, which refers actually to, wait for it, these things that we looked at. And so the code that I'm about to show you is literally what puts the ice on the cactus, okay? So we first get the ice, and then we create this masked overlay. Really what the masked overlay is this. So it's the thing that we are going to overlay that is going to be masked. Hence, masked by like the shape of the cactus. Hence, it's called the masked overlay. Okay, and then we need the mask. We need to actually get that shape of the cactus. Remember the shape of the cactus that looks like this pure white silhouette of the cactus. In order to do that, because there is no pure white silhouette of the cactus in the game's art files, we actually need to bake it. Baking it means generating it on the fly. And we go to create baked mask here. And so what this does is it uses a shader, and a shader is also known as a filter. The two aren't interchangeable, but in Pixi they call things that are in Pixi, filters are implemented with shaders. But in general, shaders you might know from like Minecraft, make your game look super juiced out. It's basically a way of telling the GPU for every single pixel, or sometimes for every point on the shape, but in this case for every pixel, what to do with it. And in this particular case, the shader that we want is this silhouette filter. It's a color overlay filter, which is a filter that I created and now we're getting really in the weeds. It does a pixel by pixel matrix operation on each pixel, and essentially all it does is it preserves the original alpha, but, meaning the original transparency, but it replaces the red, green, and blue channels. Oh, so sorry to interrupt myself, but you need to understand that pixels are represented as 4 pieces of data: red, green, blue, and the alpha channel. So you can see it's red in, green in, blue in, and each one of these red. It's actually a little bit confusing to look at this because it's actually multiplying each of the channels by a different channel. But the important thing is that there's red, green, blue, and alpha. And in this particular case, we are taking the red, green, and blue components of whatever color that you want. Our color is white. The red, green, and blue components will also be white. So this might as well have been written, replace, in this particular case, just make it white, 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 right? But this is more versatile, and we use it for other things, like when pets are starving. We use this thing called the disabled filter that tints it this color. Okay, I'm getting on a crazy tangent, but the important thing is that we use this filter that tells the GPU to go pixel by pixel and replace the red and green and blue and alpha bits of data. Literally, each thing is a series of 8 bits to store each of those components of the color, with this new color white. And performing that operation is what generates the cookie cutter, generates this mask. And the challenge is that there's like an order of operations. It's like in math with parentheses. We need to make sure that we have fully generated this mask before we use that mask to act as a mask. In other words, we need to make sure that we have fully baked this alpha transparency with the shader first before we use it for the different shader code, which actually performs the alpha masking. Otherwise, you will cookie cut after you have tried to use it as a silhouette mask, and it's as if you are just doing it. It'll all be invisible. Because it's as if you're using it on a mask that doesn't really exist yet. So for that reason, we need to basically bake it to a texture. And what that means is ask the GPU to create a special sort of like scratch pad, and please go generate, as the game is like, when you refresh this page, it's baking a whole bunch of textures. It's actually baking hundreds and hundreds of textures. But one of the textures that it bakes is this intermediate texture, which is this overlay that it needs. Okay, super long explanation, but the important thing that you need to understand is that this baking happens whenever the game first loads. And actually, that's not entirely true, because there's a subtle difference between when the game loads for the very first time and what was happening in all of the bug reports. In the bug reports, people never got the issue, as far as I can tell, the very first time they opened the game. They only seemed to get the issue when they were minimizing the game and reopening it, or switching apps on their phone. And there's something very interesting that happens in that case. And this was only something that I discovered because I was able to reproduce it using B and Jake's technique. And when I was able to reproduce it using B and Jake's technique, I was able to get a list of actually, I think I saved it somewhere else. Here it is. I was able to get a dump of all the logs in the browser when the minimization happened. And I'm going to actually show you what the important bit of the logs are here. So you can see that, remember how I mentioned earlier that when the page is not visible, so document visibility changed to visible. WebSocket closed, document is hidden. Basically, when the web page no longer becomes visible, we stop responding to the server, which means we lose the heartbeat connection to the server, which means that we are disconnected. And then when you reopen the game, we reconnect to the server, and we then need to re-render the whole game. But something very, 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 very important happens when the game is minimized. And this is like the key insight to understand the entire bug. Is this line that I've highlighted here, WebGL context was lost. Because your GPU is a super duper precious commodity, as we can see in the global world today, and everybody like buying up GPUs like there's no tomorrow to do AI stuff, your computer is very protective of your GPU resources. And when the operating system gives your browser permission to use the GPU, it's trusting that the browser is going to be a good steward of that GPU. And the browser thinks to itself, well, this guy has had this game minimized for like, I don't know, an hour, and now he's playing League. probably we don't need all of the GPU memory and all of the GPU compute for this game, because even though you're not connected to the server, it still has to, all these pictures exist on the server, exist on the GPU. And so what the operating system and the browser do is they basically take their ball back and they say, you have lost privileges to have a graphics, to have access to the GPU. And on a technical level, what happens is you revoke the WebGL context. Remember, WebGL was the spinny cube that lets us do all the nice graphics. And basically what happens is the browser tells Pixi, hey, your spinning cube is dead. And that is called a WebGL context loss. This is just a thing that happens, and the browser knocks you on the, knocks on your door and says, hey, you know how you were talking to the GPU? Well, no more. And then it gives you another message that's right afterwards, which says context restored. And that basically says, hey, look, I know we took away your WebGL context. It seemed like you weren't really using it. But now that you're back, we've erased everything that you were doing before. All these masks, all these cactuses, all these baked sprites, all that is gone. But if you would like, when you get this second message that says the context is restored, you're able to go and painstakingly recreate all that stuff. And that is what the game dutifully does. But you will notice that something very interesting happens here in the logs. It says destroying engine with 16 systems. And then it says the context was lost, and then it says destroying the engine again. And that happens, the reason that it happens twice is actually not that important, but the most important thing is that the WebGL context loss happens during this extremely critical time when we're trying to rebuild rebake all of the things that are necessary in the game. And my understanding of the bug, because it seems to be fixed now, is that there was a bug in Pixi itself and how Pixi was handling the WebGL context loss. And Pixi tries to keep track of... So one thing to understand about how all this graphic stuff works is the GPU is you should think of it like the moon. Okay? It's very far away. And we write programs here down on Earth. And in order to do anything to the GPU, we need to have an extremely long stick and poke it, right? It's not that it takes a super long time to get there. It's just that it's super different than how things work on Earth. And we don't really have direct access to the moon rocks that we're playing with to make the graphics. We actually only have very long sticks that can poke them. And when the context loss happens, it basically says, all your sticks have been cut in half, you have nothing, you got to go recreate all those sticks. And what Pixi does is it tries to keep track of all of those sticks that it's creating, and it creates hundreds of these little sticks that it needs to poke all the various moon rocks to make all the graphics work. Again, in this analogy, the moon is the graphics card, and the Earth is the browser and the JavaScript code that's running there. But there was essentially a design flaw in how Pixi was managing all of those sticks. It turns out that you create so many sticks in the process of developing a game that oftentimes game developers just won't keep good track of them. And so Pixi tries to automatically, juggle the sticks and basically confiscate sticks that aren't being used. And if sticks are really important, it tries to keep track of them. But this process isn't perfect. And they actually do this thing called garbage collection, which is a very common thing in a lot of different contexts in computer programming, where it's basically the computer trying to automatically clean up after you. But Pixi's garbage collection had some design flaws, and in the new version of Pixi, Pixi.js, if you go to their GitHub, you can see that they just released a new version 3 weeks ago that basically adds this new feature, add unified GC. GC is garbage collection. And if you really go super deep in the weeds on what changed between these two versions of Pixi, Basically, they do a much better job of snapping the sticks in half once we are told that our connection to the moon has been severed and we need to go create a whole bunch of new sticks. And in the old version of Pixi, there were some leaks in the abstraction that essentially, I believe, either caused sticks. Okay, this analogy is really getting very stretched, but essentially caused references that we had to the old system of six talking to the moon to be reused in the new connection. So imagine you minimize the game, you've got all these sticks connecting to the moon to talk to the GPU, then you minimize it, the browser decides to cut all your sticks, and we then reopen the game and we need to create all the sticks again. But Pixi has all the sticks from before and all the new sticks that it has to create, and it seemed like it was basically reusing sticks that were invalid because they had been already severed and destroyed from the old context loss, and reusing them in the new context, which is a big no-no because it essentially means that instead of getting a texture that represents the cactus, or perhaps instead of getting a texture that represents the silhouette of the cactus, you might get no data at all. And I believe that that is what is happening with this bug. I believe that the specific issue is that when you minimize the game or switch apps and a context loss happens, and then you come back to the game, there is essentially a bug in Pixi version 8.14, and actually prior to the current version, that causes it to get confused and reuse or not properly recreate the references to the GPU resources that it needs to actually perform this baked mask. And again, because the order of the baking is really important, and we need to bake it right away in order to be able to use it as a mask, it seems like that baking was breaking. And that is why the resolution, I believe, to this bug is Pixi. And this makes Pixi look like the bad guy, but actually, really Pixi is like the GOAT because WebGL is extremely complicated and nobody really wants to write WebGL code. And Pixi makes it very delightful and easy to write graphics code. And so, they pick like the new engine and all this stuff. Like really, I'm standing on the shoulders of a very powerful tool called Pixi that is kind of like a tool for building your own game engine. And that is like really what Pixi enabled me to do. So this is not really to poop on Pixi. This is really to say thank you, Pixi, for all that you do, and thank you also for fixing the bug that existed in your code that was apparently not fully handling the context loss recovery situation. And so while I am 90% sure that this is what's happening, it fits with what we observed from the Discord reports. It fits with the reproduction that B and Jake were able to prove themselves, and that I was also eventually, after like hundreds of times, able to reproduce a few times. And while this is like my mental model of this, I think is consistent with reading the source code of Pixi and like looking at the changes that they made, like it makes sense. They did actually change this GPU context loss thing. It's not just like, a coincidence that, just switching the version happens to change things. And kind of most importantly, we have not been able to reproduce this bug on the new version. So it's possible that it isn't actually fixed and it's, maybe just rarer because of, I don't know, we're getting lucky or something like that. But I am like 80% sure that I understand the bug. I'm 80% sure that the bug was not my fault. And I am 80% sure that we have now fixed the bug. And that fix will be out in the next version. So thank you for coming along. Oh my God, I've been talking for 35 minutes. That is absolutely insane. And now it's 1 a.m. I can't believe that I just did that. But I kind of wanted to make this video for a couple reasons. Number one, because I know a number of people were invested in the Blocky Cactus Challenge. And number two, I wanted to kind of like, you can see how deep this rabbit hole goes. And I spent a lot of time on this bug, and I don't always spend that much time on bugs like this, but I'm glad that I did, because the understanding that I gained in terms of like, oh man, there's this new situation of context loss and recovery, that actually probably explains many other bugs that exist and potentially other bugs that will exist down the line. And so by kind of going really deep in the rabbit hole now, my hope is that it will kind of make development faster in the future when, things like this might happen and it's like, oh, maybe this is a context loss bug. Well, now we know kind of how to trigger those. Now we know what we need to do to kind of recover from those. And so, I think that the time wasn't, well, it took a lot of time. I had fun. I mean, my just my personal weakness is I have no problem not fixing a bug, but what drives me actually crazy is not knowing what is causing a bug. And in this particular case, I just really felt like I had to get to the bottom of it, especially because like it's a new engine, it's my baby. I'm like, is there some big design flaw? If there is, I want to know sooner rather than later. But I think in the end, it really wasn't a bug in my engine. It more is a kind of just a hard problem to solve in web graphics, and I think that Pixi both created the problem and also fixed it in a much nicer way. So maybe we get proven wrong, and somebody does a screenshot of this. I haven't actually pushed it, by the way, so I'll post more updates when it's like actually deployed. But I am pretty sure that we got to the bottom of it. So thank you for listening. I know I covered a lot. It's a hard thing to talk about because it's so technical and it requires so much context. And I have no idea like the level of context that anybody watching has. Like maybe you have never seen a line of code in your life, or maybe you're like also a programmer. And even if you are a programmer, like graphics programming is super different than, other kinds of programming. But and I'm also not an expert, so like I'm trying my best to kind of like make it make sense in my own head, and then maybe make it make sense with an analogy. I don't know that I did so well with sticks poking to the moon, but anyway, thank you for listening, and I'm curious if anybody has comments or is interested in either more or less technical content like this in the future, because as you can see, I'm eager to nerd out about it, but also I know that it's not necessarily the most interesting stuff to everybody. So catch you later. Thanks for listening.